This is our day 17, reaching mastering Codeforces. So sorry for my delay. Like I am not consistent for this in this journey because my papers were going on, but now my papers are gone, so I will be consistent enough to like code every day. So my journey continue after a long break. So the thing is, I actually planned today to do a Codeforces contest, but I assumed that the contest was going to start at 8 p.m. but it was like earlier, so I missed it. But I saw like today is Wednesday and there is a codechef contest also, which is going to be at like 8 p.m. So I will be attending that. But before that, let me see. First thing we will be going to do to solve a lead code daily problem. So my streak is also breaked at lead code, so I will be trying to like maintain that also. So let's just come to this question and solve it, the POTD of the lead code. So let me reset it. The question says that map of the highest peak. You are given integer matrix is water of size m into n that represent a map of land and water cells. Okay. Is water Ij equal to 0? Cell Ij is a land cell, and is water Ij equal to 1? Then it's a water cell. Okay. If there is 1, then it's a water cell. If 0, then it's a land cell. You must assign each cell a height in a way that follow these rules. The height of the each cell must not be negative. If the cell is a water cell, its height must be 0. If it's a water cell, its height must be 0. Okay. Any two adjacent cell must have an absolute difference of at most 1. It cannot go greater than 1. Like this here. Okay. A cell is adjacent to another cell if the former is directly north, east, south or west of the latter. These sides are touching. Find the assignment of height such that the maximum height in the matrix is maximized. Return the integer matrix height of size m into n where height of Ij is cell Ij height of size m into n where height Ij is cell Ij height. There are multiple solutions, return any of them. Okay. So it's saying like the maximum difference should be 1. So here will be 1 0 2 1 output this matrix. This also is assigned another value. And this is 0 1 0 1. Okay. So the thing is, if there is any water, we only can assign to adjacent, all the adjacent cell is like 1. We cannot go further than that, and all the 1 we can assign it to the next is 2, and then their adjacents we only can assign 3, like this. Like the maximum difference should be is 1 na? If this is a matrix and these are water, let's assume. So this is going to be 1. It cannot be changed. Like if you put another value greater than 1, then the difference, absolute difference between them will be greater than 1. And this 0 absolute difference should be like this, and here will be this. Okay. And then all the ones which are present here, their neighbor should be 2, because if you put 3, the difference will be greater So here will be 2, here will be 2, here will be 2, here 2, here 2, here 2, okay, and here 2. And the difference between and the adjacent element of 2 here should be 3, like this. We can do is what, like we can do a BFS, I think. Note that this question is same as 542. Okay, we can do is like BFS and increment the value 1 by 1. That we can do only. And is there any optimal way to do it? If we do BFS, first these will be, yeah, it's only big of an operation, and a data structure Q is maintained of int and a visited, which elements are visited already, so we don't have to visit them again. That only, I think. Yeah, BFS should be, BFS can done this job, and 72% of people have done it. Or we can simply, what if there are 0 water? Yeah, there is at least one water cell, there is given, there is at least one, so it will work always, because there is always a water cell. We will calculate from 0. If there was not a water cell, like 0, if there is not a water cell here, if you see, there is not a water cell. If there is not, we can put any value, like whatever the maximum, infinite, we can put infinite here, and then infinite plus 1, infinite plus 1, infinite plus 1, infinite plus 1. So that's why so simple BFS, I think. And the constraints are also low, so we can do it with the help of for loop also. Like we just first travel wherever 0, we just increment 1, then 1, then 1, then 1. Max loop will be like big of n, whatever the cells count is the maximum, like m into n into m into n. So that is going to be n की power 4. First loop, then m into n into m into n. That will be a huge, so that's why we are going to do it with the help of BFS. So visited will be here, vector of int n, and will be row is water dot size, int m equal to is dot 0 dot. This will be a column, and here of int visited, and here will be m, and everything is false. What I am doing? Why I am putting false? Should be bool now. Yeah, and then a q, q of int na, q of row column, q of pair of int comma int, that should be there. q, and what we have to push in q? For int I equal to 0, I is less than n plus plus for j equal to 0, j is less than of j plus plus. If is water dot I dot j, what is the water? Is water equal to 1, then is a water cell. Okay, 1. If there is 1, to q dot push back I comma j. Okay, and visitor dot I dot j is equal to true. Okay, that's there. Just बाहर आते हैं हम. Then what we can do is make a vector of int travel, sorry, pair, and here should be what? 1 0 0 1 minus 1 0 0 minus 1. Okay, that should do. And then we just have to while not q dot empty. Int level equal to 1. Okay, from 1, what we only can put neighbors to it 1. Okay, then increment it by 2. Okay, that should. And size is q dot size, while size minus minus auto top equal to front q dot top, intro equal to front dot and if row is dot true. Okay, if not dot true, if no, it is already visited, so this is what we not have to check. We have to check for their neighbors. Int, what we have to put here, to v dot travel. Okay, new row, row equal to v dot c, new row is greater than equal to 0. New column is greater than equal to 0, and new row is less than n and less than m, and not visited new row, new column. Then Then what we have to put? What we have to put there? Of answer. We can make changes here also, no? In is water. Is water. New row. New column equal to level. Okay. Then so what we are going to do here is new water equal to level, and we are pushing it to q dot push q dot not push back. Here we q dot push new row new column. This is going to be pushed, and visited dot new row new column equal to true. Okay, and here level plus plus return is water. Let me check it work or not. Where I made mistake? Yeah. Okay, there zero part. No, but there is 2 coming somewhere. Expected to. And coming 1 to. Okay, let me first. What is saying?
Jai Shri Ram.
And is okay, now it's working. Let me check that it worked for everything or not. Yeah, it got accepted. There are only 59 test cases. It was an easy problem because there 72 people have solved. It's simple, a BFS problem. It's not a like huge problem, but I have done it in a very lengthy way. Let me see where is. Let me think that it can be solved more easily or not. The first thing come like we can use a loop until it fill alls, like until it get all visited. But it will be like more time consuming than this. So let me see. Yeah, it's a question of breadth first search. it cannot be solved another way. Let me see the discussion section. This should be marked as hard cause understanding description is way more than other problem. By the way, it asks you a simple find the smallest distance between every single end piece to problem is as simple as BFS. Yeah bro. For JavaScript avoiders interview, do you like graph? Only if you ask VFS. Such a weird question. Why bother with mentioning maximum at all? Simple BFS the same as lead code 5.3. Okay, let's skip this and go to the previous question. We have a lot of time until 8, so we are going to solve the previous day, the yesterday problem of the day. You can see I have skipped too much here, so I'll try to. Okay, it's a good question. So you are given a 0 index 2D array, 2D array grid of 2 into n, where grid RC represent the number of point at position RC on the matrix. Okay, two robots are playing a game on this matrix. Both player initially start at 0 0, okay, and want to reach 1 and minus 1. Okay, here each robot may only move to the right RC to RC plus 1 or down, so it can go here and here, like here. Okay, so it can go here. At the start of the game, the first robot moves from 0 0 to 1 and minus 1, collecting all the points from the cell to its path. For all cells RC traverse on the path, grid RC set to 0. Then second robot comes from 0 to n minus 1, collecting the point on its path. Note that their path may interact with one another. The first robot wants to minimize the number of points collected by the second robot. In contrast, the second robot wants to maximize the number of points it collects. If both robots play optimally, return the number of points collected by the second robot. Okay. So it basically come down to a question of Digiastra. What is the second maximum point you can get to reach at that position? Let me see. I have done that question. So the question is saying that two robots start from here. Okay, first goes here, something like he can go here, that way and that way, like this direction in a grid, like here. So the first robot goes from here, from 0 0, and collect every point, whatever the maximum point he can get until here, and the second player then do. So what is the maximum point the second robot can gain? So the first robot will take all the maximum point that he can gain. Okay, so it's simple. So you have to find the second player, what is the maximum point he can get. So it's basically a Digiastra with some changes. Second maximum distance, or second minimum distance need opposite second maximum distance need, like distance can be achieved. That is the question. I think it is a bit difficult to code, like there is like you have to make a two variable in the distance part of the Dvijastra, but I think I can code it up. Let me see, I have forget it, or I have that. So first thing will be Q. Q will be what? Row column. That is the first thing where you stand. Then distance. The first will be distance. So here vector of long. Okay. So first thing will be, what is the size? 10 to the power 4. Okay. So what will be the size is distance. Okay, long pair. Okay, got it. Q. Distance. Okay. So long.
Jai Shri Ram.
We can also do a Dvijastra, and no, there will be two Dvijastra. Okay, got it. That will be not a correct solution I'm doing. No, one sec. That is going to be removed from the we have to store the path, and after storing the path, how to mark that path? We have to store also the path we are taking. Starting from 2. To 551. How can we store the path? We can pass to what? We can pass to, no, but there will be too many now. Visited array will be not. We can store the parents of all the, like, if we go from here, the parent of this will be 2. If we go here, the parent of it will be 2. Okay, and this parent will be here, this parent will be here. So the, if we go check, and the parent of this and their parent is this, is their parent this. Okay, we can store a parent. Yeah, we can do it with the help of parent. We can create a 2D grid of parent. Okay, that can be doable. That is doable thing. Okay, and if we come back to here, and after that we put it here, like, I'm confused, but prefix sum matrix. Okay, prefix sum.